The question here is, what is the difference between discharge and seepage velocities? The velocity that we have been talking about so far, the one that appears in the Darcy's law, is what is called the discharge velocity. Let's say we have a steady one-dimensional water flow taking place through this soil specimen, and I can calculate the volume rate of water flow by this equation. I take this discharge velocity, multiply that by the cross-sectional area of the soil specimen, I get the volume rate of water flow, which is also sometimes called the seepage rate. However, if we zoom in and look at what's going on at the micro level, we see that a particle or water molecule that starts from here is following a tortuous path before it gets to the other end of the soil specimen. This is because there are solid particles which are obstructing its straight path, so it has to follow a curvy path. So the actual velocity of the water molecule is actually greater than the discharge velocity. To derive a relationship between the discharge velocity and the seepage velocity, let's consider a cross-section ABCD. Okay, and this total area is covered with solids and void. Let's say the total area is A, of which A sub S is the area of the solid particles and A sub B is the area of the void. Here I am expressing the volume rate of flow in two different ways. First, using the discharge velocity, and then using the seepage velocity. So notice that I am multiplying the seepage velocity by the area of the void space. The total area, little a, is what I call capital A over here. By rearranging this equation, I get this. After inserting h in this equation, where h is the length of the soil specimen, you can express the discharge velocity in terms of the volumes and the seepage velocity, but noting that the volume of void divided by the total volume is actually the porosity that we defined some time back, right? And therefore the seepage velocity then is discharge velocity divided by the porosity. Since porosity is always less than or equal to 1, seepage velocity is always greater than or equal to the discharge velocity. For example, if the porosity is 0.5, the seepage velocity is twice as much as the discharge velocity.